This video is going to talk about simplifying radicals when they are not perfect squares. So what I mean by that is, in class we've talked about different square roots and how to solve them. So for example, if we had the square root of 100, we would know that that's a perfect square and we could get 10. Or we could put it in our calculator and we know that the square root of 100 is 10. Right, now that's not always going to be the case. We're going to come up with some numbers that are not going to go in evenly or be perfect squares. So I'm going to show you how we like to simplify those to write them a little bit simpler. All right, the first example is going to be square root of 24. Now we know that the square root of 24 is not a perfect square. We can go in here to the calculator and we can try square root of 24, and what happens is it comes out as this really long decimal. Now the question would probably say something like, leave your answer in simplest radical form. That means that there can't be any decimals and that this needs to be written as a simplified version of a radical. So there's one way that we're going to focus on doing this, and it's to break down 24. So what we're going to do is we're going to list out numbers that multiply to 24. So what are some numbers that multiply to 24? Okay, so try to think of the different factors of 24. What you should come up with is 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Now, out of all of these factors, we want to figure out which one of these numbers is a perfect square. Now, I know off the top of my head that 4 is a perfect square. So the numbers that we're going to use to break down square root of 24 is 4 and 6. So the process that I go through in doing this is I break it down using a brace map, because I'm going to split 24 into two parts, a square root of 4 and a square root of 6. And the reason why we write it like this is because 4 times 6 is 24, or the square root of 4 times the square root of 6 is the square root of 24. So now once I have these two numbers split up, I know that the square root of 4 is 2. So that's going to come outside the radical, and I don't need it anymore because the square root of 4 is 2. Now, square root of 6 can't be broken down any further because it's not a perfect square, and a perfect square doesn't go into 6. So we just kind of leave this guy alone. Now, what we do with our two numbers here, 2 and radical 6, is since 2 does not have a radical around it, we put it on the outside, and square root of 6 is a radical, so we're going to put that on the inside. Now, what we can check is because square root of 24 and 2 radical 6 should be the exact same thing. So all we're really doing is simplifying. So what we can do is we can go to our calculator and we can check that square root of 24 is this long decimal, 4.89, and so on. And we can check to make sure that 2 square root of 6 is the same exact decimal. If it comes out as the same exact decimal, then you know that you simplified it correctly. And your final answer, or your simplified answer, is going to be 2 radical 6. All right, we're going to try another example, and we're going to do the same exact thing, or the same process over here with the factors of 24. We're going to do it with 18. Okay, so what I want you to do is take a minute, think of some factors of 18, and try to think about which one could be a perfect square. So when I write out my factors, kind of write them out on the side. I know that 1 times 18, I have 2 times 9, and I have 3 times 6. So the perfect square that I'm going to want to work with here is 9. So if I know 9 is a perfect square, I'm going to work with 2 and 9. And I'm going to split it up the exact same way. I like to use a brace map because it helps me organize my information. So now I know that this time 9 is the perfect square. And the square root of 9, if I were to do this separately in its own problem, the square root of 9 is 3. So now that 3 is outside the radical. Okay, that square root of 2, though, this little guy in here has to stay. We cannot break down the square root of 2. It's not a perfect square, and it can't be simplified any further. So once we get to this point and nothing else can be simplified, all we have to do is take our 3 and radical 2 and write it as 3 on the outside, radical 2 on the inside. And again, this is our simplified version, and you can use your calculator to check to make sure that it's right. Okay, this is the process that you have to go through when simplifying just numbers. Okay, square root of 24, square root of 18, or any other number that could be thrown inside a radical. Now, some radicals can't be simplified because they don't have perfect squares that go into them, and others you're going to have to search a little bit to find, like we did here, finding that 4 and finding that 9. All right, so this is the process that we want to be able to go through. And in class, I'll show you a way that you can do it on your calculator to make it a little bit easier. All right, the next issue we're going to come across is we're going to get variables that are going to be inside the radical that we're going to have to simplify. Now, there's two cases, and I'm going to go over each of them once here. The first case is this one here. This is our first case, and that's when we have even number exponents. Okay, so 10 is an even number, and this makes life really easy. Whenever you have a variable with an even number, all you have to do is divide that exponent by 2. So x to the 10th is actually a perfect square, and it can come right out as x to the 5th. So that's as far as you have to go with simplifying this type of radical. All right, so just remember, any even exponent, all you need to do is divide the exponent by 2. All right, that's as difficult as this one is going to get. But our second case, which is down here, is when we have an odd exponent. So an odd exponent, we have two methods to do this. But it kind of stays the same as the concept of the numbers that we did in the first two questions. So we want to take the square root of x to the 7th, and we want to break that down also into two variables, and one of them have to be a perfect square. So we just spoke about what a perfect square is in terms of exponents, and that's going to be when we have an even exponent. So I want to find the largest even number that's right underneath 7. So the closest even number to 7 is going to be 6, and then I only have 1 left over. And the reason why this works here, 6 and 1, is because x to the 6th power times x to the 1st power is x to the 7th power. And we know that rule because we add exponents when we multiply variables. So from here, as we said, even exponents, all we have to do is divide by 2. So we're going to take that 6, divide it by 2, and we're going to get x to the 3rd power. Now, we can't simplify x to the 1st because it can't be broken down any further. So once we get to this point, these are our two answers. X to the 3rd goes on the outside, and x to the 1st goes on the inside. Now, there's no real way to check this like we can in our calculator with numbers because we can't put the variables in our calculator. But it's a very similar process. Find a perfect square, which is an even exponent, and then whatever's left over is going to go here. I'll show you one other method to do this. Some people might find it a little bit more confusing, but I know there are some people who have taught this before who think it's a little bit easier. What I like to do is now think how many times 2 goes into 7. Now, it's always going to be 2 because that's what the square root really means. The square root is going to give us this 2 every single time. So I know that 2 goes into 7 3 times, and that gives me 1 left over. So with that, I can write out the exact same thing. It goes in 3 times evenly, so that goes on the outside, and the leftover is what's going to go on the inside. So you can use either of these two methods to simplify an odd exponent, but you definitely have to know how to do one or the other. So this is going to wrap up this video. So just remember the important part of breaking down perfect squares. You have to separate it into one perfect square and one non-perfect square. Take the perfect square out and rewrite your answer. When we deal with variables, okay, if it's an even exponent, it is a perfect square. So all we have to do is divide by 2. So we can even put that as a little note. It's a perfect square. And for our odd exponents, we have to go through a similar process. All right? So this is going to be asked at the end of a question if we're solving for something and it wants the answer in simplest radical form, which means without a decimal.